Hi! Hello! It's Castor Ayuban, your PWD vlogger. So today, our lesson is all about permutation of jigs. We are now in quarter 3, module 1, lesson 3, week 1, day 3. We have permutations of an objects. Objective, you're going to find the permutations of an objects. What do you mean by permutation? Okay, permutation refers to an arrangement of objects in definite order. So it refers to an arrangement, ang pagpahiluna sa mga butang in exact order. We have synonymous terms for permutation. It can be number of orders, number of arrangements, and we have number of ways, or simply order of arrangements. Changing the order of the objects being arranged creates new permutation. So you have changing the order of the objects being arranged creates new permutation. For instance, the 6 permutations of the letters F, B, and O taken 2 at a time are, we have from the 3 letters F, B, and O, we have FB, FO, BO, BF, OF, and OB. So these are pairs of the letters from the 3 given letters. We have F, B, and O. We have taken 2 at a time. So duha lang atong gamiton arong maghimutag pair from the letters F, B, O. So we have one pair is FB, next is FO, next is BO, next is BF, then we have OF, and finally we have OB. By tree diagram, we have permutation of n objects taken R at a time is equal to 3 letters taken 2 letters at a time. So this will be 3 times 2 ways. So we have, using the 3 letters B, F, B, O, then we are going to pair this with FB, FO, BF, BO, OF, and OB. So we have the 6 pairs because there are 6 ways in getting the pairs of 3 letters taken 2 at a time. So we have FB, FO, we have BF, BO, OF, and OB. So these are 6 pairs of letters from the letters given. We have 3 letters B, F, and O, or we have F, B, and O. So we have now permutation of 3 letters F, B, O taken 2 at a time is equal to, we have 3 letters given and taken 2 at a time, so there will be 6 ways. So we have FB, FO, BF, BO, OF, and FOB. The 6 permutations of these 3 letters, we have F, B, and O, taken 3 at a time are, we have from F, B, and O, so we have the 3 letter pairs from the given F, B, O, so we have F, B, O, F, O, B, B, O, F, B, F, O, O, B, F, and O, F, B. So using now the tree diagram, we have permutation of 3 letters, taken 3 letters at a time. So we have now 3 taken 3 at a time is equal to, if n is equal to r, so this is automatically equal to n factorial ways. So we have the 3 letters FBO will be paired by BO, then B for OF, then O for BF. And we have for F, we have OB, and we have for BFO, and we have for OFB. So we have the 3 letters paired from the 3 letters FBO. We have now FBO first, second is FOB, third BOF, fourth BFO, fifth OBF, and sixth we have OFB. We have now from the tree diagram, we have permutation of n objects taken at a time is equal to, we have n is equal to r, therefore we have permutation of 3 objects taken 3 at a time is equal to, we have n factorial. You have now permutation of 3 letters taken 3 at a time, there is equal to 3 factorial. So using now the factorial notation, 3 factorial is equal to 3 times 2 times 1 is equal to 6 ways. And what are these pairs? First, we have FBO. Second, FOB. Third, BOF. Fourth, BFO. Fifth, OBF. And the sixth is OFB. The permutation of n things or objects taken at a time can be denoted in different ways. We have P, open parenthesis, N, comma, R, close parenthesis, or NPR. This can be read as the permutation of n things or objects taken at a time. So we have P, open parenthesis, N, comma, R, close parenthesis, or we have NPR. So, can be read as the permutation of n things or objects taken at a time. In the first illustration, there are 3 things or letters. We have FBO, taken 2 at a time. So we have now P and R, or the permutation of 3 letters taken 2 at a time. We have now 3 times 2 is equal to 6. That is why again we have FB, FO, BO, BF, UF, and OB using the tree diagram. In the second illustration, there are 3 things taken. We have 3 at a time, where n is equal to 3 and r is equal to 3. So we have permutation of 3 letters taken 3 letters at a time is equal to, we have permutation of n is 3 and r is 3. Therefore, this is equal to n factorial. So we have now n factorial is equal to 3 factorial using the factorial notation. We have 3 factorial is equal to 3 times 2 times 1. Therefore, we have permutation of 3 liters taken 3 liters at a time is equal to 6. We have now, from 3 diagram, we produced 6 pairs of 3 liters given 3 liters. So we have now FBO, FOB, BOF, BFO, OBF, and OFB. This is very simple. We will be using the 3 diagram because the number of objects and the number of objects taken at a time are just we have small values. But if we have already bigger values, we are going to use the formula of the permutation. That will be taken in quarter 3, module 2, lesson 1, 2, and 3. So that will be our topic next week. Finding the numbers of permutations n in different objects taken are at a time is the same as finding the number of ways that can be filled are places when there are n different things to choose to. Example, how many different ways can 7 students be seated for a selfie if only 4 sets are available? Again, how many different ways can 7 students be seated for a selfie if only 4 sets are available? We have now, there are 7 students to choose from. So we have n equals 7. There are 4 sets to be filled. So r equals to 4. So we have 7 students taken 4 chairs at a time. So we have find permutation of n objects taken are at a time, and there is the 7 students, and r there is the 4 sets to be used by the 7 students. Since there are 7 students to choose from, by fundamental principle of counting, the first set can be filled in 7 ways. So we have, second, from the remaining 6 students, the second set will be filled in 6 ways. After the first 2 sets are filled, the third sets are filled using the same reasoning in 5 and 4 ways respectively. Meaning, so we have 7 ways times 6 ways times 5 ways times 4 ways is equal to 840 ways. Again, we have 7 ways times 4 ways times 5 ways times 4 ways is equal to 840 ways. By fundamental counting principle, first, so we have first set, there are 7 students compose 7 ways. Second set, we have there are 6 ways of the students to set the chairs. We have third set, there are 5 ways of the students to take the seats. We have fourth set is equal to 4 students to set, and we have the permutation of 7 students to take the 4 sets of chairs is equal to 7 times 6 times 5 by 4. That is using by fundamental counting principle. So we have now the permutation of 7 students taken 4 sets at a time is equal to 840 ways. Therefore, there are 840 different ways that 7 students can be seated in 4 sets. That is, we have permutation of 7 students taken 4 sets at a time. We have 840 ways that students can be seated. Or we have permutation of n objects taken are at a time is equal to n ways. So we have permutation of 7 students to take 4 chairs. We have 7 times 6 times 5 times 4. Again, nagbalik-balik lang ni. We have permutation of 7 students taken 4 sets at a time. So, 840 ways. What's more? So you're going to answer the following problems. There are 4 items you are going to answer. We have number 1. A hospital builds 5 new single rooms for patients. So there are 5 new single rooms for patients in a hospital. In how many different ways can they allocate the rooms if 10 patients will apply? So there are 10 patients will apply for the 5 new single rooms for patients for them to be allocated. So what will you do? By fundamental counting principle, we have for the first room, there are 10 ways of the patients to allocate the first room. The second room, we have 9 ways patients can allocate. Third room, 8 ways that patients can allocate. Fourth room, there are 7 ways the patients can allocate that fourth room. And in the fifth room, there are 6 patients to be allocated. So we have now, by counting or by fundamental counting principle, this will be now 10 ways times 9 ways times 8 ways and times 7 ways and finally times 6 ways of patients can allocate the 5 rooms. We have now 30,240 ways. Again, 30,240 ways. We have now the solution from the permutation of n objects taken are at a time, n there is equal to 10 patients and r there is equal to 5 rooms. So we have now permutation of n objects taken are at a time is equal to permutation of 10 patients taken 5 rooms at a time. So that will be equal to 10 times 9 times 8 times 7 times 6. That will be equal to 30,240 ways. And we have checked that using the fundamental counting principle. Number 2. How many 4 digits numbers can be formed from 1, 2, 3, 4, and 5 if repetition of objects is not allowed? So repetition of digits is not allowed. So dili mahimo kung ang 1 magbalik-balik, ang 2 magbalik-balik, and so on to 5 magbalik-balik. So you can form 4 digits number without repeating the digits. Okay. So we have now the first 4 digits equals 5 numbers or 5 ways of numbers. Then we have second 4 digits is equal to ways. They have third 4 digits is equal to 3 ways. And we have fourth 4 digits is equal to 2 ways. So by you have 4-digit number, we have 1 way. And by fundamental counting principle, so that you can get the number of arrangement, you are going to multiply 5 by 4, by 3, by 2, and by 1. So using now the factorial notation, we have 5 times 4 times 3 times 2 times 1. We have the answer 120 ways. So there are 120 ways can 4-digit numbers be formed from the 5 numbers. We have 1, 2, 3, 4, and 5. Solution. From permutation of n objects taken are at a time, we have 4 digits from 1 to 5, where n is equal to 5 from 1, 2, 3, 4, and 5. So there are 5 numbers or digits, and r is equal to 4-digit numbers. So you have now p or permutation of n objects taken are at a time is equal to permutation of 5 numbers taken 4-digit numbers is equal to 5 factorial. We have now the factorial notation. If we have 5 factorial, that will be equal to 5 times 4 times 3 times 2 times 1. Therefore, we have permutation of 5 objects taken 4 at a time is equal to 120 arrangement of 4-digit number. Number 3, 10 runners join the race. In how many possible ways can they be arranged as first, second, and third places? Again, 10 runners join the race. In how many possible ways can they be arranged as first, second, and third places? We have by FCP or fundamental counting principle, we have first place, there are 10 ways that runners can be arranged. In the second place, there are 9 ways that the runners can be arranged. In the third place, there are 8 ways can runners will be arranged. And we have by fundamental counting principle, so we have 10 ways times 9 ways times 8 ways is equal to 720 ways. Solution. We have from permutation of n objects taken are at a time, where n is equal to 10 runners and r is equal to 3 places. That would be, we have permutation of n objects is equal to permutation of 10 runners taken 3 places at a time. So again, we have first place is equal to 10, second place is equal to 9 ways, and third place is equal to 8 ways. So multiplying 10 by 9 and by 8, we have now the permutation of 10 runners taken 3 places at a time of that said race. So there are 720 arrangement or ways that would be produced. Number 4. In how many ways can Aling Ana arrange 6 potted plants in a row? In how many ways can Aling Ana arrange 6 potted plants in a row? So in this case, all of the 6 potted plants will be used in the first order. In the second order, there are 5 ways that potted plants will be arranged. In the third order, there are 4 ways that potted plants can be arranged. And we have fourth order, there are 3 ways that potted plants can be arranged. In the fifth order, there are 2 ways that potted plants can be arranged. And in the sixth order, there is only one potted plant will be arranged. So we have by fundamental counting principle equals 6 ways times 5 ways times 4 ways times 3 ways times 2 ways times 1 way is equal to 720 ways. These potted plants can be arranged. We have now solution. From permutation of 6 potted plants taken, 3 potted plants would be arranged is equal to n factorial. Why? Because we have n is 6 and r is 6, so that would be n factorial, where n is equal to 6. Therefore, we have permutation of n taken nr a time is equal to n factorial, where n is equal to 6, then we have factorial. This will be equal to, by factorial notation, that would be written, we have 6 times 5 times 4 times 3 times 2, we have times 1. Therefore, we have the permutation of 6 potted plants taken, 6 potted plants at a time is equal to 6 factorial. Then that would be 6 times 5 times 4 times 3 times 2 times 1. That will be equal to 720 ways. So other questions? So those were the answers of the once more. We have 1 to 4. Let's go to the assessment. We have direction. Read and understand the problems carefully. Write your answers on the answer sheet provided for you. So you're given answer sheets to answer. Okay? We have number 1. Which of the following situations or activities that involves permutation? Letter A. Matching skirts and pants. Letter B. Forming different triangles out of 5 points on a plane, no 3 of which is collinear. Letter C. Forming committee from members of a club. And letter D. Assigning telephone numbers to subscribers. So, the possible answer there is letter C. Forming committee from the members of a club. Number 2. How many different 4 digits even numbers can be formed from the digits 1, 2, 5, 6, 8, and 9? If no repetition of digit is allowed. So we have letter A, 420, B, 840, C is 120, then 1,680. So in this case, the possible answer is 120. But do not rely this possible answer. Please solve the problem. If you have solved and the answer is 120 and the answer is letter C. So that is possible answer for number 2, 120. Number 3. In a town fiesta, singing competition with 12 candidates, in how many ways can the organizer arrange the first 3 singers? Letter A, 132. Letter B, 1,320. Letter C, 920. And we have letter D, 1,716. So the possible answer there, this number 3, please solve. We have B, 1,320. Number 4, what is the permutation of 8 objects taken 5 at a time. So we have letter A, 56, letter B, 336, letter C, 1,400, and we have letter D, 6,720. And we have the possible answer here is letter D, 6,720. We have from numbers 5 to 10, refer to this given situation. 3 boys and 2 girls are photographed. In how many ways can they arranged in a row? Again, for numbers 5 to 10, refer to this given situation. 3 boys and 2 girls are photographed. In how many ways can they arranged in a row? We have number 5. If there are no restrictions, so you're going to solve. The possible answer there is letter A. We have 120. Number 6. If girls are photographed by themselves, so only girls are photographed by themselves. We have letter A, 5, B, 4, C, 3, and letter D, 2. We have now the possible answer is 2. Again, do not rely this answer. Maybe this is only a possible answer. Please solve. And we have, if boys are photographed by themselves, we have letter A, 6, letter B, 4, letter C, 2, letter D, O. The possible answer there is 6. Again, please solve. Then number 8. If they are arranged in the order boy, girl, boy, we have letter A, 16, letter B, 14, letter C, 12, letter D, 10. The answer or possible answer there is letter C. We have 12. Again, please do not rely that answer. Basin og di na mao. Kindly solve. Number 9. If no boy sits next girl. So we have letter A, 0, B, 2, C, 4, we have D, 6. The possible answer there is 2. Again, do not rely this answer but solve. And finally, we have 10. If the row begins and ends with a boy. Okay, possible answers, we have A, 30, B, 32, C, 36, D, 32. But the given possible answer there is C, which is 36. Again, all those answers, please do not rely, but you are going to solve 1 to 10 so that you can attest that the possible answers are correct by solving the problems. Okay, for your next understanding, you're going to study quarter 3, module 2, lesson 1, week 2, day 1. And this is all about solving problems on permutation. So this time we're going to solve problems using solving problems on permutation. That is, we are going to use the permutation of n objects taken are at a time. Okay. So we have now, thanks for watching. This is your teacher, Castro Ayuban. And again, correction is under your care. Thanks for watching. Katong wa pa maka-subscribe sa akong YouTube channel, please subscribe and please do not forget to hit the notification bell so that you can follow my next videos. Once again, thank you for watching. Videos, please click here and subscribe my YouTube channel. Thanks for watching.